45 years ago, in 1980, we built the first commercial wind farm on the shoulder of Crotch Mountain in southern New Hampshire. That farm was 600 kilowatts. Some of the wind farms we're building today are as much as 1,000 times bigger than that farm in southern New Hampshire. To say that we've come a long way on wind energy is an understatement. Now, there's a lot being said about wind energy these days, but here are the facts. Global wind capacity is now 1,100 gigawatts. That puts wind at 8% of total global capacity. And what might surprise you is that's actually more than solar. And despite recent legislation that makes it feel like we're moving backwards on wind, remember that the US is a small part of a much bigger global trend. To be specific, the US is actually less than 10% of what is now a $200 billion global market. And the rest of the world isn't slowing down either. Last year alone, 55 countries installed 23,000 turbines. And these turbines are marvels of heavy industry. Costs have come down, efficiency and reliability are up. Even more impressive, by most estimates, the technical potential of wind could power the world 10 times over. So, look, we should celebrate. Wind works. But, and there is a but, I think we can do it even better. Because while wind power has grown into a massive industry, we've really only done it with one design, what I sort of affectionately call 3 blades on a stick. And we've primarily driven the cost of wind energy down by making the turbines bigger, and then massive. And that's driven us into an engineering corner. Installation costs are high because you need a crane to assemble the crane that builds the turbine. And the sheer size of these machines means that you need heavy industrial infrastructure in order to install them. And so I'm here to suggest that the model that got us here is not the only model that will get us to where we need to go. And where do we need to go? We need to generate a lot more energy. By most estimates, we're at least a 32 gigawatt shortfall in just the next few years. And for context, 32 gigawatts is the electricity demand of California and Florida combined. That's a lot. And closing the gap will not be easy. A nuclear plant like the one pictured here takes 5, 10, maybe more years to build. Gas turbines are on back order, and technologies that affordably work in one geography may not work in the other. And so I'm calling for the next era of wind power to be based on 4 key principles. Make it simpler, more robust, faster to deploy, and geographically flexible. Because if we can do that, we won't just expand wind energy, we will unlock resilient, affordable power. Now, I started thinking about these performance challenges and the value of reliability early in my career as a Marine F-18 pilot. I had the privilege of taking one of the most advanced fighters in the world into combat. And over 12 years, I learned that those advanced systems were absolutely incredible until they weren't. My buddy summed it up perfectly when he said, none of that advanced stuff matters without 2 engines and 4 wheels. The basics that always work, simple and robust. After active duty, I spent nearly a decade at Google and Google X working on Makani, which is an airborne wind system that could harvest energy from the wind more efficiently than a conventional turbine. And one day, at our offshore test site, I looked up at our prototype and reflected on the weeks of preparation it took for just a few short hours of operation. And I found it ironic that as we worked, a conventional turbine a kilometer away was just spinning the whole time. And that's when it clicked. Just like the fighters I flew, the impact of advanced technology will only be realized if it's simple and robust. That's how wind will reach its full potential. So let's take a closer look at a conventional wind turbine, and I think you see why we can do it better. Conventional turbines are often more than 500 feet tall. They're made with massive and unique components. They utilize low-volume manufacturing, and installation requires trucks that shut down highways and massive, massive cranes. More importantly, despite energy costs coming down for a decade, they leveled off a few years ago. And then, more recently, costs went up. In addition to costs, big wind has geographic limitations. So here's a map of where the wind blows in the United States. And here's where America's turbines are actually installed. As you saw in the previous map, wind is strong in more than just these places, but these clusters exist because this is where heavy industrial infrastructure exists. Now, we're not going to solve all the world's energy needs with wind power alone. You and I both know it's not windy everywhere. Different geographies have different resources. If you're Norway and you can produce 98% of your energy needs with hydropower, then yeah, do that. If you're Arizona, use solar. But what if you're Japan? Japan doesn't have a meaningful oil and gas resource. It doesn't have a great solar resource. Nuclear is understandably off the table, at least for now. It has wind, but not the wide roads and wide open terrain needed for massive turbines. That puts Japan in a tricky spot. It needs options. So what if wind energy didn't have to be massive to be meaningful? How could we shape wind into a flexible, fast to deploy, and low-cost power source? The good news is that innovators are working on novel wind systems that could do just that. SkySails is building and selling a kite that is accessing higher altitude winds. Icewind is building a vertical axis turbine that can be installed in more extreme weather conditions. And Windcatcher is developing a turbine that could make floating offshore wind feasible. Not quite a full departure from today's technology, but Nobber Wind is lowering the cost of installation by making towers out of high-volume parts. And still others, Aeromine and Accelerate Wind, are making wind power from rooftops. Now, not all of these technologies are going to make it. Like all startups, there will be more failures than successes. But every idea begets another idea. And one of these ideas could spark the next revolution in wind power. A portfolio of new technologies that are simpler, more robust, faster to deploy, and geographically flexible. And this isn't just theoretical. It's a matter of leveraging both physics and market realities. Now, many of us know the story of the Model T, a Ford produced using standardized parts in just 93 minutes. That compares to the 12 hours it took to build its predecessor. And Ford achieved this by using common materials built into simple, robust parts at high volume. And what if we applied these same principles to wind technology? What if installation looked more like assembling furniture than building a skyscraper? What if maintenance was more like changing a tire instead of rebuilding an engine? And here's a look at a novel track-based system that is 95% steel and aluminum made into 58 unique parts. That's 58 parts compared to a conventional turbine of the same size that uses 1,500 unique parts. It follows the footsteps of Henry Ford, common materials built into simple, robust parts at high volume. And this design enables the manufacture of gigawatts in weeks, something that today takes years. And this could be gigawatts across Wyoming, remote parts of northern Canada, and maybe the global south. It could also be deployed on floating platforms, which would bring low-cost energy to small islands. Or it could be deployed to disaster relief areas or to power offshore data centers. As the CTO of Breakthrough Energy, Eric Toon, says, energy is prosperity. Affordable, abundant energy, he says, is the single most essential foundation for nearly all facets of human prosperity. I'm here to say energy is also security. If we realize this vision, nations stabilize, our environment is protected, and people thrive. But we must innovate. We must innovate in wind. We must find a better way. And we must make wind work in more places. From the farms and ranches in the United States, to the mountain towns in Europe, to remote villages in Africa, and small islands in Japan with narrow roads. That's the opportunity, multiplying our options. New kinds of wind energy, building energy that works for everyone, simple and robust. So whether you're an engineer, an investor, a policymaker, or just somebody who cares about the future, I challenge you to stop accepting the status quo in wind. Because when we get this right, when we unlock wind's full potential, we're not just generating electricity. We're generating prosperity and security. Thank you. Thanks.